Hi there guys, I'm Lewis. Today I'm going to be your youth tutor, as you can see by my jumper right there. Today I'm going to be doing GCSE proportion. It's considered one of the more difficult subjects in the GCSE syllabus. So yeah, let's get down to it. Question 1, as you can see here, a mass m kilograms of a solid metal hemisphere is directly proportional to the cube of the radius r centimetres of its circular base, and we are given the information when r is equal to 8, m is equal to 24. So in part A here we've been asked to express m in terms of r. So I'll quickly do up here what we've been given here in the question. So we've been told that the cube of the radius is the equivalent of the mass. So is directly proportional, to the mass. So the mass is directly proportional to the radius cubed. So now what we need to try and work out is exactly how to express m in terms of r with the information that we've been given here. So we can put in what we know here about the r. So we can do 8 cubed, which I believe is equal to 512.
Are we going to put a proportionality constant into this? So we can say m equals kr cubed.
Yeah, I was going to do that.
Oh, I see. Okay, sorry. Okay.
Okay. So now that we know that is equal to 512, we can go m is equal to k r cubed. But now obviously we know what r cubed is, so we can bring that underneath here. So that means k is equal to m over r cubed, which we know to be 512. So therefore it's going to be 24, which we've been given here.
Would you substitute that in actually, please? So you're going to substitute 24, 512, I see.
So that's 24 over the r cubed, which is 512. And then obviously you probably need a calculator to work that out. I'm going to do it to 3 significant figures, and it comes out as 0.047, I believe it was. So now we know what the equivalent. So now we're going to put that back into this top equation up here. So we know how much we need to times r cubed by to get the mass.
That's right.
So that means the mass is equal to 0.047 r cubed. And I'll do a little red underline there.
Yeah, that works for expressing m in terms of r, and here we have m equals 0.047 r cubed. Great.
Cool.
Okay.
Easy peasy.
So moving on.
Okay. Part B. The radius of the base of the hemisphere is 11.5 centimeters. Calculate the mass.
Yeah.
So this is literally just as simple as plugging in this new bit of information here that we've just been told into what we just worked out here. So I'll quickly rewrite this up here. So m equals 0.047 r cubed. We've now been given obviously the radius, which means that obviously we can go m equals 0.047 times 11.5 cubed, which I unfortunately cannot do on my head. And I believe it comes out as 71.5 kg, again to 3 significant figures, and that there is meant to be a small k.
Thank you, that's great.
Cool. I'll do that in blue underline, shall I?
Yeah, with that flourish, we like that flourish. Okay.
Okay, so part C. The mass of the hemisphere is 425 kilograms. We've been asked to calculate the diameter of its circular base. So to do this, we're doing a very, very similar thing to what we did in this last question, apart from this time we've been given the mass and not the radius. So again, I'll put what we worked out earlier, which is m is equal to 0.047 r cubed, which obviously, as I said, we worked this out earlier. So now we don't have the radius this time, but we know with this bit of information here that the mass is equal to 425 kilograms. So we can go 425 is equal to 0.047 r cubed. And then obviously we just have to simplify this and work out what r is. So we have to get r by itself. So we can move the 0.047 here underneath the 425. So that would become 425 over 0.047, and that there is equal to r cubed. So now what we have to do, basically we have to get rid of the power. And the easiest thing to do is just to literally move it straight across, and it becomes a cubed root, and you just take off the power just like that. Yep. So that means r is equal to the cubed root of 425 divided by 0.047.
And what does that work out?
That there, I believe...
In your head, go on.
I believe it's 20.8.
That's incredible.
Off the top of my head.
Incredible.
I hope that's right. But we have not been asked to work out the radius here. As you can see here, it says the diameter. That is definitely a big one of reading the question thoroughly. So the diameter.
I was wondering if you'd noticed that. Okay.
Yeah. So obviously we need to work out what the diameter is. So you basically just need to double the radius. So the diameter is going to be equal to 41.6 centimeters. If I've been correct there.
And that looks good.
I'm going to do that in a green underline this time.
That looks absolutely great.
So as you can see here, we worked through this question. It's once you sort of get going, it is quite sort of simple. It's just plugging in the information and knowing how to rearrange the equations.
It's that first part, isn't it?
Yeah, it's just that first section A really. If you get that nailed, then these two sort of slot into place quite easily.
As long as you're careful, as you say, with reading the question there and getting the units right. Yeah.
Exactly. And obviously you've got to, of course, read the question where it says diameter and not radius. And yeah, apart from that, I hope you guys enjoyed the video. Please watch this as many times as you need. Don't forget to watch this video after you've done the worksheets and not find out the solution straight away. I'm looking forward to giving you another video in the near future. So thank you very much.